Hello students, today we will discuss about work. Now what is work? What is work? Work, something we do. Now what kind of thing we do? We think, that is also work in some other respect. We tell that one that okay, we think, we will respire, whatever we do, we are doing some work. But in physics, work is having something different. The definition is something different. Here work is of mainly two factors. One, it is done or it may be done if work is there, and the other thing, if there is a displacement. If there is a displacement, that means the body moves whenever there is a work. Now suppose, think in this way that there is a block, you are giving some force. If the block moves, then only work is said to be done. If the block doesn't move, we say that there is no work done. Now let me discuss this one in a bit detail today, and what we can do here, we can first discuss on vectors, because the majority of this part, the concept lies in vectors only. So let us discuss a bit on vectors. Now as we know that there are two type of quantities, physical quantities. One scalar quantity, the other one vector quantity. Now what do you mean by vector quantity? Normally what we say a student of class 6 to 8, they will say, what they will say? They will say, sir, quantity which is having magnitude and quantity which is having direction. So these two, so this is a quantity which is having both magnitude and direction, is considered vector quantity. But to be specific, there is also another thing to qualify for a vector quantity. Any physical quantity, to get qualified to a vector quantity, it needs to have three conditions. What are those three conditions? What are those three conditions? First, it needs to be having magnitude definitely. Second, it needs to have direction. Third, should obey vector addition law. So these are the three major factors due to which we consider a physical quantity as scalar quantity or vector quantity. If any of these three is lacking in any one quantity, that quantity will be considered as scalar quantity. For a vector quantity, need to have these three conditions fulfilled, then only we can say it's a vector quantity. Clear to all of you? I think you are clear. If any confusion arises at any point of time during this video, you can leave a comment in my comment section, and I'll try my level best to respond, to give a response in a proper time, maybe in a faster way. Let me see how I can respond to your comments. Now suppose what I said for work, suppose there is a force which is acting on a block, and the block needs to be moving high on an inclined plane. Say the inclined plane is at an angle of theta with the ground. What will happen if I give a force in this direction? What will happen? The force, if I give it here, since it's blocked like this, so what will happen? This will try to move upwards. That means the block at any point of time, it will try to move in this direction. That means the displacement, if the block comes to this position now, then what will happen? That the displacement is along the inclined plane, but force is given in this direction only, means force is always horizontal. Now if force is horizontal, then from here what I can do, see here, displacement is this direction, so force in this direction, that is F. If I copy this part down, what will happen? If I copy this part down, what will happen? See here, force was acting in this direction, displacement in this direction, and this was the angle between them. Agreed? If any confusion, I'm telling repeatedly, please leave a comment on the comment section, and you can call me back. Even my WhatsApp number is also given to my students who are from school or my coaching center. You can always call me back. Even you can also WhatsApp, and those students who are not in direct contact with me, they can leave comments, and I'll try to respond, give my full response within time. Now this is your displacement, this is your force. While solving this one, or while to find out the work done, what we do, we tell that work is a scalar product of two vectors. Scalar product of two vectors. What do you mean by that? Scalar product of two vectors? Scalar product of two vectors means that work will be represented by force is a vector, one arrowhead above. Scalar product means also dot product. So this is the representation or vectorial representation of work, where we say work is a scalar product. Scalar means dot product, so I have put dot over here, dot product of force and displacement. This one then written as F is cos theta. Concentrate on this term, small term, S cos theta. What we have done, F is cos theta. See this part. What it says actually, work is a product of force and the component of displacement. This one is the component of displacement. So work is the product of force and component of displacement in the direction of force. Now what do you mean by this? Understand carefully. I am telling it repeatedly. I am telling it again. Work is the product of force, or you can say in more detailed way, work is the product of magnitude of force and the component of displacement in the direction of the force. In the direction of the force. Now see here. In this diagram, this is called vectorial representation. This is vectorial representation. What I am doing, I am dropping a perpendicular over here. I am dropping a perpendicular over here. Now as I drop a perpendicular over here, then this is a right angle triangle. This is a right angle triangle. Now I have taken the magnitude of force that is there moving horizontally, and what I want to have this component which is in the direction of the force. Now if I ask you, how will you represent this part? Say this is O. So from O to say A, how you will represent in terms of S? S is this full quantity. S doesn't mean the arrowhead only. S means the total length of the arrow. S means the total length of the arrow. S means what? The displacement from its initial position to the final position. Now so S is the hypotenuse over here. I asked you to represent this part only, OA. How you can represent OA? OA is the base. In any right angle triangle, you need to remember, if this is theta being given to you, the opposite of theta stands your perpendicular, and obviously this will be your hypo, so this is your base. So what I am asking you to tell me how you can represent OA in terms of displacement S. Right angle triangle, theta, opposite of theta is perpendicular, so this is your base. Now just remember, for sine and cos functions, what we know, say there is sine theta. Sine theta means what? Perpendicular by hypotenuse. Perpendicular by hypotenuse. If I take this one as perpendicular, this one as hypo, and this one as base. Perpendicular by hypotenuse. Cos theta, we know base by hypotenuse in a right angle triangle. So I have asked you to represent B, that is base. How I can represent? I can take out this side, this one, cross multiplication. So base will be your H cos theta, and in this case what is H? H is nothing but displacement, S cos theta. So I hope you understood this part, how we have come to this conclusion, or how we have come to this answer, that is S cos theta. So S is the hypotenuse over here and cos theta is the cos function of angle theta. So in this way what we understood, that work is the product of force and the component of displacement in the direction of the force. Component of displacement in the direction of the force. So this one, this OA I can also write, just rub out base and I can write here is cos theta. So I am repeating again. So what is scalar product? This is scalar product. What scalar product says? If there are two vectors, scalar product says if there are two vectors, then the scalar product is the product of the magnitude of one vector, or you can tell this one in this way as a first magnitude of first vector, magnitude of the first vector, and product of the magnitude of the first vector and the component of the second vector, in the direction of the first vector, component of the second vector in the direction of the first vector. That means the product of force, that is the first vector, and the component of displacement, that is the second vector, the component of the displacement in the direction of the force. See, S cos theta is also in the direction of the force. So I hope you understood. Now the same diagram if I represent in a different way, how we can represent now? Say the block is here again, condition is almost the same. This is again the inclined plane, we have angle theta over here, and now force is applied in this direction. There is made a hook and a force is given in this direction, that is force. Clear? If force is given in this direction, now what will happen? The displacement will also be in the same direction. Displacement will also be in the same direction. So that is your displacement again. Here what happens? Say if I give this the same direction, if I take it in the horizontal plane, and if I see that force and displacement both are in the same direction, that means the angle between them theta is 0. The angle between them theta, that is theta is 0, or we can say 0 degree. So if I put now F equal to force into S cos 0 degree, what is the value of cos 0 degree? That is 1. So we'll have Fs. So till class 8, or say till class 8 or 9, we know that force is what? Work is what? That is force into displacement. We always say, just immediately we answer force into displacement. But we need to remember that probably that force and displacement both are having the same directions. That means the angle between them is 0. So we need not to take any component of that. So that's the reason we tell that work equal to force into displacement. Now the same thing if I represent in a bit different way now. Suppose this, there is, again I am drawing this one again. So these are the three conditions. First you saw this one, now the second one. Again the inclined same plane is there. Now there is made a hook, and say from here a force is acting. Again just the earlier one what I have said, force is given in that direction, but it is obvious, or we can consider, not obvious, you can consider that this block is bit heavy than the force. That means if I pull that block, if I pull like this, the block will not come out, it will not happen. But what will happen, since the block is heavier than the force what I am giving, what will happen, this block will move in this direction. That means probably it will coming at this position, still the force is acting in this direction only. Are you getting it? So force is given in that direction only, although the block is not that too light that it will come out of the block and it will come out of the floor and it will move along the force. It is not going to happen. What is going to happen, that this block will try to move along the plane, So what was the displacement then here? Then this is the displacement then from this portion to this portion. If I take this one as, let me draw over here. So this is your O, displacement, this is your displacement now, that is S. And what is the force here? let me take from here only, let me take the force from here. I can take this one as the force position. So from here, say this is your force. Again what we see, there is an angle theta. So this was the angle theta, that is the angle between force and displacement. In the earlier one what we found, that force and displacement was not having any angle, that is angle was 0. So 0 degree means cos 0 degree is 1, we used to say that work equal to force into displacement. But again here theta, that means there is some value of angle. Again as I said, scalar product, what scalar product says? What scalar product says? That it is the product of magnitudes of two vectors in such a way that the magnitude of the first vector is multiplied with the component of the second vector, which is in the direction of the first vector, or sorry, first vector. I am repeating it again. So what is scalar product? Scalar product says that it is the product of magnitude of the first vector and the component of the second vector in the direction of the first vector. Clear? Now here the first vector, now if I see here, just see here, if I consider this one, in this case I have considered force as the first vector, I have kept it over here in the first condition only. Here if I see, let me take the horizontal component of horizontal direction only, on the plane only we are considering. Say S is the first vector. S is the first vector and the second vector is F, but we are going to take this component of force, that is in this direction of the displacement. So we are taking F cos theta. If I write this one as Fs cos theta also, then also doesn't matter, both the things are same only. But while considering Sf cos theta, we need to understand that we have taken the component of force in the direction of the displacement. That means the component of the second vector in the direction of the first vector. So again we have got three expressions we have done earlier. The first condition, this is the second, there was the second one, this is the third one. Now we are having three conditions. Out of this, if you are being asked that when we can say work is 0, or you may ask that sir here work is 0, on what condition you will say? First condition is that suppose there is a force given, but the block on which you are giving the force is not moving, that means displacement is 0. If displacement this S is 0, obviously the work will be 0. Like pushing wall, obviously we are not all khalis, so we cannot have that strength that will push the wall and the wall will fall, then only the work will be done. For a khali it may be the work may be done, but for us work will not be done. Understood? So that's the major factor. You need to understand that whenever there is a displacement, then only the work is said to be done. Obviously force is there, otherwise how we can expect displacement, correct? So that is our condition first. Second thing, when we can say work is done. Now let me rub some of these things and we will. So first one, when displacement is 0, now consider that there is a ground and there is a block. What we are doing, we are lifting this block here, or we are lifting this block here with us. We have lifted it, and after taking this one we are moving in this direction. That means there is a person, say there is a person who lifted the block here, lifted the block and is moving in this direction. In this case also, if you see here, just see here, displacement is in this direction and the force that is on the block is acting towards the center of the earth, that is gravitational force. So by holding this one, say a bottle, if I hold this one like this and then I move, then what will happen? The bottle, if I leave the bottle, what will happen? The bottle will fall down. That means there is a force acting towards the center. There is nothing but gravitation, is known to all of us. So force acting downwards and we are moving with the bottle. That means the bottle is displaced in this direction. From here the bottle is displaced towards this side and the force is acting downwards. It is acting downwards in the line of my body. So if I see there that what I see, or if you consider that there is an angle of 90 degree, then force is toward the displacement towards in that direction, and the force is acting as a gravitational force is this. So if I write work now, then F is cos 90 degree, value of cos 90 degree 0, then work done is 0. So in this way we can find out that whenever there is a 90 degree angle difference between the displacement and the force in whatever condition it may be, then the work done is always 0. Now there are also other examples which you will find in your books or in other cases in your life, when suppose a man is carrying a suitcase in his hand and is walking on the road. With respect to gravitational force, the man is not doing any work. Now isn't it funny? It is very funny. The reason is, as we are carrying that weight, we feel that we are carrying it, we are giving some energy out there, but in terms of physics and with respect to the gravitational force, actually we are doing no work. But again, if I am holding a bag and the bag is, I am giving it a force as if I am going with the bag, then the force and the displacement is in the same direction. In that case, work is done. So it is very funny, if I consider the gravitational force and if I am walking in that direction forward, then always there is a 90 degree angle in between force and displacement, and the work done is 0. Now there is also another example here. I can give you another example also. If you see, suppose there is a body moving in circle, and the body is tied to a string. Suppose there is a we can take the body as a stone also, and we are rotating it. What is happening here, in each and every place the direction is in this direction. Displacement, if I consider very small displacement, over here, say a very small displacement here, then this displacement is taking in this direction, and the centripetal force is acting towards the center. Again the same thing happens, it is 90 degree difference. This is displacement, this is the centripetal force. So again the same thing happens, cos 90 degree is 0, and we get this value of as work done as 0. Now as we have discussed about the 0 work done, we will also discuss on negative work done. Now what do you mean by negative work done? Negative work done means the angle between the force and displacement, that is theta, will be either more than 90 degree, it is considered, or less than equal to 180 degree. Even if you go above 180 degree also, till 270 degree, you are going to get negative work done only, but still we consider this condition as negative work done. How? If you see, work done equal to F is cos, if you go for the maximum one, 180 degree, when we consider this equal to minus 1, there is minus Fs. So negative work done. Now some of the examples where you will find there is a load, if we move it up, that means we are giving a displacement, and that displacement is against your force of gravity, so that is 180 degree. So you understood, I think, more than 90 degree or less than equal to 180 degree is considered as negative work done. Or in any case, if this theta, say work equal to F is cos theta, the value of this, if negative, it will consider as negative work done. Value of this, if considered as 0, it will be as 0 work done. Now after this we will go for even negative work done as lifting. You can also find out, if you are having a block over here, you are giving the body is moving this direction, that means this is your displacement. Frictional force acts always in the opposite direction. So in this case also the displacement is this direction and the frictional force is acting in the opposite direction. Here also it is 180 degree out of phase, so again negative work done. Now we are going to think of positive work done. Now positive work done is always less than 90 degree, less than, when theta, say theta is less than 90 degree, it is always theta when less than 90 degree is always positive work done, because whatever you get below the 0 to 90 degree is always positive. These are all the cases what we have already discussed. Say force is here, displacement is here. If you find it, these are all less than 90 degree angles. So in this case we get work done as positive. That is positive if this angle, that is theta, is less than 90 degree. Hope you understood. So there are three conditions. of work, or we name it in three ways: zero work done, negative work done, and positive work done. There are also other examples you will find in your books and all. If any confusion arises, please let me know. You can put your comments in the comment section if for any queries and all. I'll try my level best to assist you. Okay, thank you for the time being. We'll come with other topics also. This topic was mainly to focus on students of class 10 and 9. Obviously we will go in detail of this for your class 11 syllabus as well as your JEE mains syllabus. Thank you.